Alright nerds, so today we're going to talk about thermal energy being transferred or transmitted through convection, or convection currents. So our goal today is to be able to understand how that happens. How does thermal energy get from one place to another using convection currents? And you want to be able to show us you understand that, you need to be able to draw it, really. Draw it and talk about that diagram, but that's what we're going for. So convection is basically when we heat up mass amounts of fluid. Now, fluid can be a gas or a liquid. Fluid just simply means it flows. So when we heat up mass amounts of fluid, and it then moves away from the heat source. So if we come down here, right, so here's our flame, and the hot water, as does hot air, rises. So this is kind of an idea you've been familiar with since you're a little kid. Like hot air rises, we know this. But this is the actual implications for it. So this is the good thing about science. As you go further into it, you stop learning what is happening and you start learning what that means for future things. So that's pretty cool. All right, so we heat up our water here. Here's our heat source, and it moves up. And as you're heating it up, because the particles are sort of bashing against each other as they heat up, they become less dense, right? So they're not as tightly packed. So as they're less dense, we know that a less dense object will rise and a more dense object will sink. So the less dense objects, which is the water, moves up. So the hot water is less dense, it rises, but as it rises, it uses that energy to lift it. You know, if you lift something, it takes energy. So it loses some of the energy and it becomes less dense again. So where does it want to go? It wants to go straight back down. Unfortunately, it can't do that. It can't do that because these particles here, right, like they're all like, I'm hot, I'm moving, and they're charging up. If it wants to go back down, it can't, it'll just bump into them and they'll gain more energy and start to rise up. So what it does is it moves over to the side here because the particles here aren't as dense. So here it can charge down, and it does. And then as it loses energy, it moves over to the side here and comes down and down and down. And then it cycles in to take the place of these particles which are moving, which means you've now got a current going this way on the bottom of the water, underneath, and on the top of the water you've got current going this way. Okay, so that's currents, and that's a convection current, and that's a really cool thing, and it's because this one heats up, so the particles become less dense and move up. Then as they lose their energy, they want to go back down, but they can't go straight down because they'd interfere, so they move over to the side here, and then they just cycle around. So as it heats up here, they leave. We can't have a vacuum there, so these particles flow into position. And the same thing's happening this one. But you'll notice that from the heat source, the particles are moving. You get different currents away from the epicenter of that heat source. And here's a really simple diagram here. So the hot water rises, goes up, and then comes like that. So convection above a hot surface occurs because hot air expands, becomes less dense, and rises. That's wind, by the way, as well. See, it's called wind. Ocean currents, tectonic plates. Like this is why the Earth moves the way it does. For example, if we heat it up here, we've got this little convection current going this way. This convection current, put two wood blocks in the middle. They are going to go in opposite directions. We see the same thing at the tectonic plates, right? So here's this convection current charging around. That's pretty good. This one's charging around at a rapid pace, like really, really fast, of like a couple of centimeters a year. But we're talking about a lot of molten rock. So it's fairly slow, but you're moving a large amount, so it's going to take a lot of energy to do that. And that's why the tectonic plates move. Like that's how that works. And it's also how air works. So if we get rid of those little scribblings, so the hot air heats up. Okay, hot air heats up. The air goes up, but then it's cooling down. So the air becoming less dense. It's rising, but it's cooling down. It can't come straight back down, so it moves over to the ocean, and then it sinks. And this is why if you're standing on the beach, the breeze nearly always, I can't think of a time when it doesn't, comes in from the ocean because the ocean's cooler. So, and that's because of things like things like sort of the way water absorbs heat in the water in the air of here. By the way, this is not to scale. Like here, like we're not just talking about this is the beach and this is like 20 meters away. This might be hundreds of kilometers that those winds are traveling. Probably not if you're in New South Wales because you've got these big things called the Blue Mountains that interfere with everything. But in most other places, yeah, like that, this wind current might be hundreds of kilometers in size. Yeah, anyway, that's that. So I hope that made sense. If you have any questions, put them in the comments below. This is actually a really interesting topic. It's one I really love. You can tell because I got all sort of wistful and dreamy about it. And yeah, so what am I doing? Pressing buttons, willy-nilly. Yeah, so ask questions, put them in the comments below. We'll get back to you as soon as we can. Thanks for listening, and we'll see you next time. Bye now.